okay, is when you came in here and blogged. Okay, this box right here, something, depending on if you're using Firefox or Internet Explorer, which one, it's maybe a different box that pops up here. Either way, they want a username and a password. Okay, and this is the part I wanted to try last night, but I think if you're remoting in, you might have had to put this CRCSD in, okay, from off school. If you're here at school, you just got to put in your username here at school and your password to get to the website, the blog site that's associated here with Kennedy. Okay, at least the one I created here from the Kennedy website. Okay, so if you're remoting in, does everybody know that right there is the backslash? Okay, it goes up and to the left. Okay, then your username. Okay, like that. And then your school password should get you to here. Now, when you're here, this is not your school username and password. You have to create a username and password for this blog site. And that's what caused some people trouble, is they were trying to type in their school username and password. Okay? So to do that, you click register here, hit agree, and this is where you type in your email address, okay, and your username and whatever password you want here. Okay? When you do that, okay, you can then come in here, and now you have a unique, whatever you want to call it, and your username and password, people will see you in the forum by that name. Okay, so if they want to see you by your name, then that's fine. That's fine. If you want to be anonymous of some sort, so if you're called the Geometry Ace or something like that, okay, they won't know who the Geometry Ace is if you want to be anonymous. Okay? Yes.
I forgot my username, so tried to make another one so I can.
I had some people have to change an email address sometimes to get a different one. It's associated in there. I had people have troubles with that last year. If you had the same email address, so I guess you'd have to sign up under maybe a different email address, and I think you may be able to do it. Okay, I haven't resolved that issue 100%. Okay, but this right here is then your password that you created. You get in here to the forum. Okay, now in the forum here, eventually what I'm going to do is, yes, you went in here, okay, and you saw all what the blog was and everything. You can go in there if you want it. Okay, and we could see what everybody and who everybody blogged. A lot of people blogged here under the one I created originally. Okay, this hour I just started using those wonderful icons right here. And of course, did you just see your wonderful comment there? Okay. Okay, yes. Right there we have Ross's wonderful icon there too. Yes. Okay. So that was just kind of to get in there and do something. What your vision, or at least my vision of how this is going to be useful for you. I hope we use it. Okay, and what I want to contain here's this. Okay, I get in here, and let's go to last year. Okay, last year I'll create a circle folder for you. Okay, it won't be down here under advanced geometry blogs. Here it'll be under in this folder up here. There'll be a circles folder just like this, and you click here on that circle folder. Okay, and in that circle folder, you can kind of see, oh yeah, there was a topic in here. And it's not just a folder, like I said, blog. There'll be a topic that will make a folder out, and it'll say, like tonight, secant worksheet. Okay, and I don't know if I have one. There's one over review worksheet that I clicked on. Okay, and this is what I'm talking about. Maybe you know who this is, maybe you don't by their name. Well, there's Jason, there's Mark, and there's Juliet. Okay. If you want your username to be anonymous, then you can create something that's that way. Either way, the purpose is to create communication mathematically. Okay, so you have to you can come in here and Juliet did a heck of a job here explaining exactly how to go about doing problem number 9. You don't have to sometimes do all of this explain it. Sometimes it only takes a sentence or two to go in there Okay, like this one right here. I guess Julian was there again to Katie, so she asked a question, you know, about this problem number 9 on the chord worksheet, and she's quickly explaining it to you. Okay, sometimes it's tough with all the symbols. You got to use, you know, the word radical or square root, okay, in there to kind of talk about things. Okay, but if it all comes down to whether the class gets into it and starts posting things in there, it ends up being a good resource, for you to get in there. Okay, how many times have you been home and this one problem you can look at for 10, 15 minutes, and then you finally, you know, do as I probably would, just throw the dang thing across the room, say a couple bad words, and say, I don't like geometry. Okay? Whether you've ever thought that or done that, that's, you know, up to you. Okay, or you have to come in the morning. Okay, well, coming in the morning is still a great option, but just maybe quick post this. And if somebody's on it, on the web, you know, also on the blog site, said, oh, I know how to do that, and then answer it, great. If nobody gets on and answers questions, they just post questions. You guys have done blogs before, right? Not you. You've never blogged before in any other class? No? In English classes, a lot of times they'll have you blog about a topic. You know, you get in there and carry a conversation. This is a different way to do it. So, all right? Questions then about the blog site? If you still can't get in, try today and at school and then come up here and maybe I can help you out. Okay? All right. Last night's assignments. Anybody try this one? Right here? I don't remember what number this is. Is this 16? Yeah, 16. I will give you one hint. I was a very poor artist, either, I don't know if it was on purpose or not. It said this right here was collinear. Okay? So if that's collinear and T is the center, what did I just draw right there? I just drew a diameter, right? Right. This may be helpful to you to write that is 8x units long. That's what it says in the problem. It then says the distance. The distance is measured so it's perpendicular. I'm going to ask you this question. This distance right here, if it's perpendicular, what will it do to this chord? I know it's not a radius, but couldn't I make it out here like a radius? So we have that conjecture. If a radius is perpendicular to a chord, it bisects it. That'll eventually be important here. But the main important part is this distance right here was 3x. What else did I give you on this problem? HI. Why did I give you HI? I gave you something down here. HI is coming over there. There has to be something else I gave you here in this problem. What else was good? How does that help us though? It's an arc right here and an arc right there. All right, so it's the converse statement. Remember we said if congruent chords are equal, the arcs are equal? Why did the converse? The arcs are equal, so now these chords are equal. Okay. I'm going to stop there. I think that'll kind of get you going in the right direction there on that one. Okay. I may come back to number 17 if you want me to talk about 17. This one right here is kind of critical of where do you go about drawing things in. I personally, there's 2 ways to do this one. I always end up drawing in a radii. You notice I do that a lot, like right here. See there's a radius? And I do that and it ends up always creating a right triangle. Sometimes it's even a special right triangle. So keep that in mind as you're doing your homework tonight, finishing this worksheet up. Okay? All right, go ahead and put that off to the side so I know you have your attention. Because today is one of the best days ever. No, second best day ever. Yours, my day was the best, wasn't it? Okay. All right. The second best day is the day that I created a conjecture. I get my name put in the book today. We have conjecture 1, 2, 3, conjecture 70. Today we get to Johnson. You guys are looking at me, what? How do you have conjecture? Who do you think you are? Well, I don't know, maybe I was bored. Maybe I wasn't. I don't know if you guys knew my wife was a math teacher too, so maybe we sit at home and talk about math. Actually, we don't. We never talk about math. But I was sitting there using Sketchpad one day, and something just hit me. This is what happens. All right. Okay. What I had here is I got to thinking about this. Okay, I got these measurements right up here. Maybe I need to enlarge them a little bit. You see those better now? Okay. This is the angle right here that I have. And what I did is I measured this arc right here, okay, and I measured this angle right here. And when it's out here on the center, central angles and arcs have the same measurement, right? And then what I did is I noticed as I pull this closer to the circumference, what's happening to the size of the angle? It's getting smaller. The arcs stay the same, but don't you see the angle getting smaller and smaller? Until it finally got to the circumference, and we made this conjecture. What was the conjecture about inscribed angles? It's half. But this is what I said, why do I have to stop there? This is where my first conjecture came in. I just wanted to know, is there a relationship when this thing gets out here further? And I just kept on seeing this, and I said, well, there has to be a little bit more than a direct relationship between that arc, because that arc's not changing, but I can keep on making that angle get smaller and smaller and smaller. So there had to be some other relationship here between not just this arc, but this angle right here didn't intercept just that one arc anymore. See this? Doesn't the central angle intercept one arc? Doesn't this inscribed angle intercept one arc? How many arcs does this angle intercept? 2. So that prompted me to say, hey, I wonder how big that is. Okay, so I came over here, okay, and I measured. Okay, in fact, okay, what I did right here, okay, is I did a little bit of investigation myself. Okay, and I said, okay, there's a big arc right here. And does everybody see the relationship here of, you see the angle there? Do you guys see the angle over here that I'm talking about? It's right here. I drew it this way because what I ended up calling this angle right here was a secant angle. You guys see how this is a secant here and that's a secant there? I just wanted you to see how, you're going to see it on most of your homework assignments, like this. Okay, but I drew it like this so you can see why I called it a secant angle, because it's made from two secants. Okay? And this small arc right here, if that's 10 degrees and that's 100 degrees, I came down here and I just kind of started writing down some data. And I wanted to know, how do I take a 100-degree arc and a 10-degree arc and get 45 degrees? If I had an inscribed angle, I just cut this arc in half. If I had a central angle, those things were the same. If I have a secant angle, there has to be something these arcs had a relationship together to get that angle. So I just started moving things around. Okay, I can make this maybe 120, let's say. Okay, so I had 120 and 10. This ended up being 55. Now I can change this angle right here too. Gets it out here a little bit further. Right there, so maybe this was 120, 50, and then this is 35. And maybe an easier one here is if I make this 40 here instead. $120, 40, and 40. I just kept on changing these numbers around, getting as much data as I could. Maybe we may want to make this small, like 60 right there. Whoa, that could be way out there. Let's bring it back, please. 60 and 60. That's 20. What do we see? Okay, maybe I don't have all this here seen it yet. Make this look. Make this 80 degrees. Okay. We got 80, 20, and 30 this time. Go ahead, discuss most of your groups. See what if they notice the same thing you're noticing. What do you see here? What do we see in there? Essentially, what do you see? Arc 1 minus arc 2, that's 90. So if I divide that by 2, I get this. Or what could I have done to this angle to get that over there? I could double it. So let's see here. I think I did that right over here. Okay, or I could come up here and I could take that right there. Is what you're saying. Take that and divide it by 2, I think is what you're saying. Okay, right there. That will give me this angle right there. So those two will be the same right there, right? Or double this angle and I get this. Does that always work? If I move this around, and wait here. Is this always, you're looking at those numbers on my finger right now. That always working no matter where it's at. I had this little animate thing right here. And this is what I did. I animated this thing around so I could see if this secant intersected, does it always work? Is it working right now? No. Those numbers aren't matching up. Where's the secant angle at right now?
That's because it's only intersecting.
It's inside the circle, so that got me thinking. That's why I made more than one conjecture. Okay, we're only going to deal with one today. I got to thinking is, whoa, if this secant angle ends up being outside the circle, this works great. See, even right now, is it working again? It'll get here. You got to get the numbers there. And there, it is back, so that the numbers are. When it's outside, is it working now?
It has to intersect 2 arcs.
It has to intersect 2 arcs, but it was always intersecting 2 arcs. But I think the intersection of the secants, where do we want that intersection to occur? Outside. When it intersects outside, we're all good. But right now, this thing's going to go to the inside here in just a little bit. Okay, and when it's inside, is it ever the same? No. So I had to do something else tomorrow. I'll show you here in the next couple of days what I did to figure out the inside ones. Okay? But with that said, right here, that led me into, what do I do? You don't have to do this example. I have one at the end I want us to do. Is what do I do to solve this one right here? Okay, how do I go about setting this one up? Okay, what would be, Lindsay, what would be my geometry setup on this one? Geometry setup, yeah.
Arc 8
Okay.
minus arc 80.
So everybody agree that's our geometry setup that we have? Algebra setup then, 100 minus 40 divided by 2. Looks like we come up with 30 degrees. Is that right? Do my math right there? Very difficult conjecture? No, not bad. Okay. Does it get more difficult if I ask you to find an arc? That's a 32 right there. That's a 120 right there. Jake, you want to help me out here? What would be my algebra setup? I'm sorry, my geometry setup to find this arc right here? What was the conjecture again? Yeah.
It was the big arc
The
minus
big
small
arc. So I got
divided by
CD minus
B.
BE
Divided by 2.
divided by 2 equals angle A. Now, on this one right here, you may want to manipulate your geometry setup so it doesn't have a divide by 2 in there. So I think it might be easier here. When I have 120 minus BE divide by 2 equals 32, what are you going to have to do anyway with this divide by 2? Times by 2. So is this the same conjecture? If I was to come over here and have CD minus, oops, CD minus BE equals 2 times angle A. Is that the same thing? Okay. I think it doesn't matter which way you solve it. And then 20 minus BE equals 64. You do have to be careful though there. I do have a negative arc. But what's going to be my answer? It's going to be a negative right over here, 156. Did I do my math right there? Okay, 56. So BE's on. It's 56. Not a bad conjecture, right? You guys are, when you guys looked at it, he's going to have a conjecture. Right? He looks in your face and went, oh man, that's, okay. You thought it was going to be Euler's line difficult, didn't you? Okay. All right, I want you guys to try this one. Okay. What I did on this one is I put a couple more concepts in it. Okay, I'm going to utilize this conjecture to find other information. Here, I'll blow this up for you. Wouldn't that be nice if you just do that to your boards all the time? You know, I have this over here. I mean, technology anymore, they're going to get there to the point that I'm going to say, shrink. And it's just going to, you know, all of a sudden, you're not even going to have to touch it anymore. You're going to have access before, well, maybe not before you guys shoot out of college, but tablets are going to be something that's going to replace that notebook paper, I know, eventually. They already have some cool things out there right now. It's like a pen that comes up and projects your thing on your desk. When you're right on your desk, like with a pen. They already have that already out there. It's pretty cool. So then you just hit save. It's, the image of the computer is right there on your desk. So you just, you don't even need a tablet. It's pretty cool. Right on desk, you know. You have a special pen that's pretty helpful. Yeah, it's kind of like this pen right now. If I start doing things. Days, you know, I see you guys out there looking bored. Hold on, Dr. Berger, he'll teach you. I think Dr. Berger is his name. I think my sense of humor is bad. You should listen to him. My Algebra 2 classes say, okay, we're going to hear Dr. Berger today. Oh, got that guy, dude. All right. I'll throw that off to the side there. have all of our information in the picture. Okay, so this right here would say, okay, WR, and that is this arc right here. This is where I'm going to kind of use my highlighters. Okay, because sometimes this stuff is going to get very busy out here. And I'm going to have WR is 11x minus 4. Okay, I'm going to highlight this arc right here. That is 3x plus 8. And this angle here, 2x plus 2. That angle right there. That is one of the Waldo rules that we're going to add on after number 4. It's going to say find your secant angle. Okay, look for that Johnson conjecture number 1. Okay, first thing was always look for central angles. Then we look for diameters. Okay, then we look for inscribed angles. Now we're going to look for secant angles. So if I was to use the Waldo rules right up here, I would say, are there any central angles up here? Any diameters? There is a diameter here. This is going to be helpful here in a little bit. Okay, that diameter, but right now that diameter doesn't help me get started. The central angle or the inscribed angles here don't help me get started either, but the secant angle does. Shelby, help me out here. What's my geometry setup going to be for this thing?
Arc WR minus arc YQ divided by 2.
Okay. Do you want to divide these by 2 or do we want to times this one? Which one's going to be easier to work with in algebra? Multiply? You agree or not?
Oh, well, I just did division.
You did?
Yeah.
Did both of these numbers, when you subtract them, come out even? Because what happens if they're odd numbers? Do you want the fraction answers then? That's the part you got to watch out for. You guys get what I mean by if these right here, when you subtract them, they come out to be odd numbers? That could cause a problem. So I think it's sometimes safer to avoid dividing into a fraction by doubling. Okay? All right, so we'll double the angle Z here instead. Okay? All right, go ahead and solve that. I want to see what you get for X. So we need a little kick here in the butt here to remember common mistake. Watch out. Don't worry, it's not the one that I say foil. That one didn't occur. But there is an error here. I'm doing my math in my head right up here, and I'm going to get 4 for an answer for X. Is that what everybody came up with? X is 4? Then you're all wrong, because I never make a mistake, right? Where? Look at my work right now. Why is mine right or wrong? I'm never going to know if I'm wrong until you give me that. Luis? Something that we need to remember to do is put parentheses around this. If you don't, there is very commonly, okay, maybe not today, maybe not tomorrow, but then unfortunately we don't want it to happen on the test. Create the habit now, distribute, so that ends up being a -8. So in fact, this is not a +4 here, this is a -12. Okay, that's going to make a little bit of a difference here because I think I get X to be 8. Then after that, well, 4x minus 12 equals 20. 4x equals, yeah, 32, so x is, okay, going to be, all of my lights just went, everything just crashed. Well, I'll do it the hard way, 'cause I don't like this thing, but 32 divided by 4, and I got x equals 8. You guys get x is 8 also, right? Okay. Now I wanted to find these angles, this angle and this arc, and this is where my Waldo rules come in. The first thing I look for up here is, well, after I substitute this stuff in, I got 88 minus 4, which is, did you guys get 84 there? Am I doing the math right in my head? 24 plus 8 is 32. And maybe I need this angle out here too. 16 plus 10 is 26. Did I do my math in my head right? Okay. Now, I will use these Waldo rules. The first thing that I have is there any central angles here? No. Is there any inscribed angles? There are. Maybe I need them. If that's 84, does everybody see that one right there? Okay, that's going to be 42. There's another one right over here, and that's going to be 16. Can we ask to find those? WYR, I did, yes. So there we go. Find that one. 42. Okay. So I got my inscribed angles. After inscribed angles came my secant, and I already got my secant numbers up here. Okay. I got to go back, and I forgot one. There's a diameter that I have to have. This diameter right here. How does that help? What's the diameter do this one?
Well, it's a circle and two circles.
Okay. Okay, so it's a smiley day, even though my smart mark crashed. Okay, that always makes you guys smile, right? The smiley faces up there. Okay, so we have 180 degrees there. I only want to find out, okay, this amount of it though. Oh, rainbow. There we go. All I want is this part of it. How do I get that? All I want is that part of it right there. What do you think? Not seeing any ideas how I can find that part right there. I have numbers up here. I got 42 and 16. I think this right here is a 32. I'll just write it out here. Whoops. Yeah, it's not working. This is 32 right there. It is parallel. Okay, so I think you're talking about, I know it doesn't look like it, but you're saying those are parallel right there. So this arc and that arc right there have to be the same. Okay, so that means this is 32. Okay, so if I come up here and take 180 minus 64, because that's what these two are together. Okay, I'll get 160. What you guys think? Alright, just conjecture number 1. One of many to come. So excited. Look at this smile over here. She's excited. Can't wait to come tomorrow. Maybe we get to learn about number 2. She's really resistant right now. Okay, your secret worksheets. I have it right up here. You show me, okay, worksheet 7.4, and I will give you the today's worksheet. you didn't get a 7.41 all done, work on it. Get it done here. And then I'll tell you how many to do on today's worksheet.